What's going on, you guys? So today we're gonna work on insert into a binary search tree, and we're gonna complete this with Kotlin. So let's take a look at the instructions and think about how we're gonna go about and solve this. Okay. So we're given a root node of a binary search tree and a value to insert into the tree. So just to remind you, a binary search tree, the left subtree, so everything that's connected to the left, all values will be less than the node. And likewise for the right subtree, so everything connected at the right, all values will be greater than the node value. So that's how you define a binary search tree. So let's see. So we're going to get the input to our function will be a root node and a value. And we're going to try and insert that value into the tree. Okay, so return the root node of the tree after the insertion. It's guaranteed that the new value does not exist in the original BST. So we get a value, we search through the tree, figure out where we want to insert it, we insert it, and then we return the main root node, like the full tree after insertion. Okay, so here's an example. We're given this tree here, and our value is 5. So we search, we see, okay, 5 is greater than 4, so we need to search the right subtree, so we go here. And now we see that 7 has no subtrees. And since 5, so if we compare, okay, rewind, 5 is less than 7, so we go to the left subtree. Oh, there is no left subtree, so we'll set it equal to 5, and then we return the full subtree. Oh, so there's 2 accepted answers here, so interesting. So either of these are a valid solution. That's interesting. I'm not sure how they're getting this second one, but the first one makes sense. Okay. All right, so let's walk through how this is going to work. So what happens if root is null? Right? So in Kotlin, this question mark that tells you that tree node could be null. So if tree node is null, so if root is null, we'll just create a new tree node and set its value to value. So what happens when we do that? It sets val equal to val in this case. It's unfortunate. So val is a keyword in Kotlin, so they have to put these backticks around it so that they can reference it correctly. Okay. So, all right, we've dealt with a null root. So let's say root is not null. Then what do we do? So we got to compare. So if val, we compare val to root's value. We're just going to call it value. It's a little bit easier. If val is less than value, we'll search within left subtree and right subtree otherwise. Once we reach a leaf node, we'll insert val. and we'll know whether it's going to be a left subtree or a right subtree based on this first comparison. So let's walk through that in the example. So we're given this subtree here, and our val is 5. So we compare 5 to 4. 5 is greater than 4. So what we're going to do is we're going to set 4's right subtree. So in this case, we're going to set treenode.right equal to a recursive call to the function, and we're going to give it this right subtree. So we're going to say root dot right is equal to insert into BST root dot right val, or vice versa. And so in this case, we compare 5 to 4. We say, okay, 5 is greater than 4. So what are we going to do? We're going to set root dot right equal to insert into BST root dot right 5, right? So let's see how this is going to look. So we're going to say if root dot val is equal to null. And so before we do this null check, we have to give it a question mark to signify that this could be null. After we do this check, though, we don't have to use the question mark, because Kotlin knows that if we reference null down here, if we reference root down here, it cannot be null because it's already passed this check up here. Okay, so if root is null, we're going to return a tree node with val. Okay? Okay. So now we know root is not null. So what are we going to do? We're going to compare val to root.val. So let's say if root.val is greater than val, what are we going to do? Oops. Okay, so if val is less than root.val, we want to search in the left subtree. And so what are we going to do with the parent's left subtree? We're going to set it equal to whatever is returned when we search through the left subtree. And then otherwise, we're going to search the right subtree. And so once it searches through this whole subtree, eventually, so it's going to get to 7 in this example. 5 is less than 7, so it's going to set root.left equal to insert into BST root.left, which is null, comma 5, right? So at this point right here, here's the call that happens. Wait, let's not put this here. So we're right here, right? 5 is val. Here's the call that's happening right here. Insert into BST, and root.left in this case is null, and val is equal to 5, right? So we're setting root.left equal to insert into BST null comma 5. So in this case, it's going to return tree node 5. This will equal tree node 5 right here. And so at the end, we'll just return root. We'll return the original tree. Okay. And something interesting. So let's say root is null and val cannot be null because we have not given this a question mark. So we're asserting that val will never be null. If root is null and val is not null, then we're going to return a tree node val. If root is not null and we have a val, we're going to return a tree node. So either way, we're returning a tree node. So this is actually incorrect. Tree node will never be null, or the return will never be null. We'll always return a tree node. So we can get rid of that there, that question mark. Okay, so let's just double check our code. Okay, so we got a compile error. Let's see what that says. Expecting property name or receiver type. What do we do wrong here? Expecting property name or receiver type. Let's check that out. Expecting property name or receiver type. It looks like this guy's doing a leetcode as well. He's doing a binary search tree. He might be doing the same problem as us. Okay. Oh, okay. Let's see here. Here's the problem. We didn't surround this in backticks. So val is just an unfortunate choice of a variable name in this problem because it's a keyword in Kotlin. Like either a variable is either a val, which is constant and doesn't change, or a variable, which is able to change. So we just forgot the backticks here. I think this should work. Okay, yeah, let's see. Okay, there you go, guys. So here's a recursive solution. It's less code than the iterative solution, so it's a little bit makes it a little bit easier to understand. But anyways, the key insight here was we're setting, once we've handled the null case, we're setting the left subtree equal to the recursive call. So we're going to take the left subtree, we're going to set it equal to whatever that tree looks like after we insert our value. And the same thing for the right subtree. We set the right subtree equal to whatever the tree looks like after we insert the value. And so that goes down and finds the right place to insert at the leaf node. So thanks for watching today, and check out for go ahead and subscribe, like the video, and check out the next video. See you guys.